What is augmented reality? Broadly speaking, augmented reality is unique in that it is a combination of the real world and a digital overlay. Augmented reality serves to bridge the gap between our physical world and the digital one. Within this environment, digital information is applied to our real world. The ultimate claim of this is to provide clarity in data where there was none previously. The most widely accepted definition of augmented reality is that it combines the real and the virtual, is interactive and real-time, and registered in 3D. While virtual reality and augmented reality may appear similar, they are in fact very different. Augmented reality is best seen as a way to enhance what we perceive in our daily lives. This may be with prices showing up on items in a grocery store, or the correct route displayed while in traffic. Virtual reality is a complete disconnect from the real world. Your senses are only being shown a digital creation. There are two main types of hardware used to display an augmented reality to a user. There is a monitor-based and a head-mounted display. Between the head-mounted displays, there are two major types: the optical see-through head-mounted display and the video see-through head-mounted display. Some examples of monitor-based augmented realities would be the first down marker during most football broadcasts. Additionally, baseball cards now come with augmented reality functionality to enhance user experience. The optical see-through head-mounted display allows for the user to see the real world. However, it does not allow for occlusion or the ability for the software to remove or edit items out of the view. It also does not allow for a wide field of view for the user. The video see-through head-mounted display is very similar to the optical see-through, but it allows for more modifications by the software. It is capable of occlusion, time delays, and the ability to present a wide field of view to the user.
Augmented reality works by letting the user see the real world with computer-generated images that overlay on objects in the real world. It adds graphics, sounds, haptic feedback, and smell to the natural world as it exists. It blurs the line between what is real and what's computer-generated by enhancing what we feel, hear, smell. The surrounding real world of the user becomes interactive and digitally manipulative. Two different approaches can be used in AR technology. One approach is a marker-based application, which is software that recognizes a particular pattern that will overlay a digital image at the point on the screen. Another application, which uses the ability of certain devices to record its position in the world and offers data relevant to that location.
Augmented reality has been around since the late 40s and early 50s. Ever since its inception, it has rapidly grown into every aspect of our lives. Now more than ever, we use augmented reality on a daily basis, whether we are conscious about it or not. The Sensoroma stimulator was one of the first pieces of gear that made its debut. It felt like you were riding a motorcycle in real life. Next came the Ultimate Design by Ivan Sutherland. These inventions are now considered very early beginnings of augmented reality. The term wasn't made popular until Tom Cadell, who was a researcher at Boeing, gave it that term. So, in retrospect, AR didn't really fully come out until the 90s. Even though the term had been created, it still wasn't mainstream yet. That all changed in 1998 when an application was developed to be used as lines over a football field, so the people watching the game at home could see the plays in relation to the game. So it was the first debut of AR interacting with the real world and a user. After that, AR started to expand even more, finding its way into all areas of life. It's in gaming, navigation, fashion, art, commerce, medical, etc. Right now there is about $1 billion in revenue for AR. However, that is expected to grow to new heights of $120 billion as we discover new advancements in the field moving forward.
As discussed earlier, augmented reality can be applied to any of the 5 senses. Normally, one would expect the augmentation to align to the same sense. Another prevalent tendency is to load virtual data into the visual realm. However, we can use the concept of cross-modality. Cross-modality ensures high performance for certain tasks when the technology cannot replicate the sense, when the specific senses are diminished, or to prevent excessively impacting the stimuli of a single modality. Optimizing cross-modality ensures the best performance in an augmented reality environment. The future will be filled with trial and error efforts to find the most efficient means of presenting data from any of the senses. Some examples include the use of hearing or touch to assist the visually impaired, the use of an electronic sniffer to identify dangerous situations, visual or haptic cues to assist the deaf, monitoring of cargo loads or structural integrity. Now let's explore commercial products. Available products for visual augmented reality include software applications and small displays connected to glasses. Under research and development, augmented reality is being explored using head-mounted displays with cameras. Further into the future, electronic contact lenses will provide an augmented reality interface with discretion. There are products that also provide haptic augmented reality. Today, the Geomagic Touch allows real feedback in digital 3D modeling, and GM has introduced lane alerts that produce vibration in the driver's seat. Researchers are studying glove and mounted components that allow for a more complete interactive experience. And in the future, we may wear a second skin that uses vibrations to mimic interaction with real objects and allows us to manipulate virtual ones. So how does augmented reality propose to impact the way we move? Collaborative efforts such as SPHIL, shown here, will improve map, model, and landscape-based navigation over time as technology miniaturizes and improves, and as explorers provide more detailed information. Inside the automobile, displays and gauges can be moved from the dashboard to the windshield to provide us useful information while keeping our eyes fixed on the environment. Existing systems, such as proximity indicators, adaptive cruise control, and crash avoidance systems, can feed into the visual display to provide additional information. Finally, navigation information can be presented as virtual images overlaying our real paths. Many concerns will need to be addressed before augmented reality becomes pervasive. There is a lack of standards when compared with other technologies like HTML. Cooperative educational and industrial conferences will help establish common use standards, and government oversight will need to be established to address safety concerns. Despite all of the concerns with augmented reality, we can expect major strides in public availability in the coming years.